This class we will look into operating systems and we will get familiarized with three terms in the operating systems. So this is an introductory class where to understand the basic terms and concepts. So in this lecture I will be taking the three topics: tasks, processes and threads. Let's see what's a task is. So you do a lot of tasks every day. So task is something which we have to do, which we do every day. So in terms of operating system, it is a program in execution and the related information. It's also known by the term job in the operating system. Now, two things which is very important with respect to the task is one is the priority, because there will be different tasks which has to be executed, and each task will be assigned a priority. And second thing is schedule. You have to tell the time of execution, or you have to decide what is the time at which it is to be executed. So these two things is very important with respect to a task. And we can see that a task is composed of several processes, threads. We will see these two terms in the coming slides. So what is a process? A process is a program or part of it in execution, or it is an instance of a program. So instance means there's a program, you are giving it a value and you are running it. So that's an instance. Next time you can give another value and run. So that is what we call it as instance. And we have to understand that this process needs different resources like CPU, IO devices, memory, etc. So this also has to be decided. And it is always executed in sequence. It is one after the other, one instruction after the other. So it is sequential in execution. And it is a process which helps us to execute concurrently, which results in the efficient utilization of CPU and other resources. So next we are going to see the structure of a process. So a process mimics a processor, a physical processor. So a process will have working registers. It will have to store the status, so there will be status registers. A program counter will be there to point to the next instruction to be executed. It will have memory and stack pointer, which is pointing to the stack. Now a process which mimics or which has all the properties of a CPU, it is called a virtual processor. And virtual processor is waiting for the physical processor. So when the physical processor is free, when it gets its turn, the physical processor get loaded with all these parameters, or with the register, status and program counter and stack pointer, and the process is executed. Now the memory has three parts: stack, data and code. So stack is used to temporarily hold the variables, data is used to hold the global data, and the code memory will have the instructions that are to be executed. Now important thing is the stack memory grows downwards and data memory grows upward. Suppose in the memory map the allocation is from the address 2048 to 2100. Stack occupies the top area. So from 2100 it comes downwards, whereas data memory it grows upwards. So if the data memory is allocated from 2070, it will grow upward. The next location will be 2071. Next location will be 2072 and so on. But stack memory grows downwards. Now we will see what is a process life cycle. So a process will have different states. By the way, what we are going to see is a generic representation. Later we will see for different operating systems what are the different states, specific states. So why the states are important? Because for each of the state, the resource allocated will be different. The CPU allocation will be different for each of the state. And changing from one state to another, it's called the state transition. So here we see there are 5 different states: created, ready, running, blocked, and completed. So the initial state is called the created state, where no resources are allocated for the process. Now when the resources are allocated, or when the process is loaded into the memory, it goes to the ready state. And there it is scheduled and it awaits for its turn. Now running state is a state when the instructions are executed one after the other. Now in the state, if it is interrupted, it will go back to the ready state. Meanwhile, another thing that can happen is during the execution, it can wait for another event, or it can wait for a shared resource. So once that event is over, or when that shared resource is available, it goes back to the ready state. The state where it is entirely completed is called the completed state. Now we will see what are some of the specific operating systems and the states. So one operating system is VxWorks. So VxWorks has ready state, pen state, delay state, and suspend state. Another operating system is MicroC OS2. In it, it has dormant state, ready state, running state, waiting state, and interrupted state. So it differs for different operating systems. We will look into process management. Now, process management has different steps. That is what we are going to see here. We will see the details about it in the coming sessions. So process manage consists of creation, setting up memory space, loading the processor code, allocating system resources, setting up a process control block, otherwise called PCB, and it also controls the process termination and deletion. Now we will see the third term called thread. So what's a thread? It is a single sequential flow of control within a process, or we can say it's a lightweight process. Now a process can have multiple threads of execution, and the interesting thing is the threads will share the same address space, but it will have its own status, PC, and stack area. We will see something more. This is what happens inside a process. So there will be multiple threads. So here you can see in the figure there are thread 1, thread 2, thread 3. So we can see in this case the thread 1 is creating 2 child threads, and thread 2 is actually the child thread 1, and thread 3 is child thread 2. So a lengthy process or a task is divided into smaller sub-functionalities, and each sub-functionality will be a thread. Each thread will have its own stack and registers, but the code memory and the data memory will be shared. Now the advantage of this is it is going for a better memory utilization, because there is a shared address space. The data memory and the code memory is shared, but the execution speed is increased, because if it occurs that one thread doesn't require the IO, it is waiting for some IO operation. So the CPU is also waiting. So at that time, a thread 2 or a thread 3, another thread can take up and use the CPU. So there is an efficient CPU utilization. CPU will be continuously occupied by one of the threads, and it will improve the speed of execution. Now, some terms. Thread standards. So it is a set of libraries which is used for thread creation and management. And there are some standard threads, like one is POSIX, which is Portable Operating System Interface. It has an ANSI C-based library from GNU. There are Win32 threads which are used in Windows operating systems. There are Java threads are there. So these are some of the thread standards. Now another important term is thread preemption. So what does it mean? It means stopping the currently executing thread so that all the threads will have an opportunity to get executed. And thread preemption depends on the operating system. And changing from one thread to another thread, it is called the thread context switching. There are two types of threads. One is user level threads and another is kernel level threads. So user level threads, it occurs inside the process. So they do not have kernel or operating system support. So there will be multiple threads inside the process, and the operating system treats all this as a single thread. In kernel level thread, what happens is they are actually individual units of execution, and operating system considers each thread as separate. So summarizing, we saw what's a process. Process is a single execution of a program. There can be a same program can run at different times. So we create two different processes, and each process has its own state, which includes its registers and memory. Lightweight OS, the process runs in the same address space. In heavyweight, each process runs in a separate address space. Threads, they are processes that share the same address space, are often called threads. And we see that tasks, they are composed of several processes or threads. Now we will see some university possible questions which can come for the university exam. One question can be distinguish task, process and threads in operating system. Another can be explain the structure of a process. One possible question is explain process states and state transition. The concept of multi-threading is also an important question. So with this we are coming to the end of this short lecture. So please go through this. I have referred this book, Introduction to Embedded System by K.V. Shipu, second edition of that, and some other websites also. So thank you.